Hello everyone. Today we are going to discuss one more PYQ of transportation problem to find the initial feasible solution by the Ojel's approximation method. In this question I have chosen from the IFOS 2018. This question has been asked in IFOS 2018. So we are going to solve this question by the WAM method, that means Ojel's approximation method. By this method only we have to find the initial feasible solution of the given transportation problem. So first we have to check that the given TP is balanced or not. How to check? Add the capacity, or you can see also here the supply capacity, whatever 7, 9, 18. So 7 plus 9 plus 18, 7, 9, 16 and 18, 34. And also check the demand, 5 plus 8, 13 plus 7, 20 plus 14, 34. That means 34 equal 34. That means capacity equal to demand or demand equal to supply. That means the given transportation problem is a balanced TP. That means balanced transportation problem. So now we can proceed by the Ojel's approximation method to find the initial feasible solution of this given TP. So first what we do in the Ojel's method we already know, we have already discussed about it, how to find the initial feasible solution in the WAM method. So now we'll start first find the what smallest and second smallest in row wise. Means what is the smallest is the 10 and second smallest 19. What is the difference of these two? Smallest is the 9, so simply write here 9. Same in second row, 30 and 40 are the smallest, so now we choose the 10. And in last row, 8 and 20 are the first two smallest, so take the difference of 20 and 8, we'll get the 12. Similarly, we have to do same thing in the column wise. Find the smallest and second smallest, and 40 and 19. Take the difference, we'll get the 21. Similarly, here 30 and 8 means we'll get the 22. In this case, 40 and 50 difference is the 10, and in last 20 and 10 the difference is 10, and that are called the penalty. So row and column, after finding difference, we know that in this method first check which one is the maximum penalty. So here 21, 22, 10, 10, 12, 10 and 9, 22 is the maximum. That means in this column we are getting the maximum penalty, so we have to choose this column and we have to allocate in this column whatever the possible, we have to allocate maximum possible value in this column. So now after getting this column, check which one is the minimum cost in this column. So 8 is the minimum, so allocate as much as possible. Here capacity is 18 and demand is 8, so this cell can get the 8. So now this has the finished, this column has finished, so just cancel out. Now update everything, so this one is now cancel out, and here 5, here 7, here 14, and here after updating, after 8 only the 10 remain, here the 9, here the 7. Now repeat the same process again. It's again find by row wise and then column wise penalty cost, then decide row or column, then allocate as much as possible. So again we will repeat the same process by row wise. Again we will get the, now this has been finished, so only in these three we have to check. So again we will get the 9, we will get the difference is 9. In this case we will get the, now this has been finished, so next to smallest are the 40 and 60, so we will get the 20. And in this case again now 20 and 40, so we'll get the 20. Now by column wise we'll get the same thing here, the 21. In this column is finished, so just forget about it. Now here which one two smallest, again we'll get the same thing, that means 10, and here we get the same thing, that is the 10. Same first which one is the maximum, so 20 is the maximum. 21 is the maximum, so 21 is the maximum. That means again we are getting the column, so in this column we have to allocate as much as possible. So in this column check which one is the minimum cost, so 19 is the minimum cost, so we have to allocate as much as possible here. So capacity is 7 and demand is 5, so obviously this cell can get the value 5. So now this column also finished, So now we have to update everything. So now after allocating the 5, remain is the 2. Here 9 is still remain. Here 10 remain. In this case, that is now finished. This is also finished. Now after updating the 7 and 14, next we will get now this two column has been finished already. So after updating everything, again we have to repeat the same process. Again we have to repeat the same process. Okay. So repeat the same process. These two has been finished. So again find the difference in the rows. So only two are here. So 15 and 10 is the now 10. So we'll get the here difference is the 10. In these two we'll get the difference is the 20, and in these two we'll get the 70 and 20. So difference is now 50. Now column wise, obviously these two has been finished. Just forget about it. In this column we'll get the again same 10, and in this again we'll get the same 10. So now which one is the maximum? 10, 10, 50, 20 and 10. Which one is the maximum? Now 50 is maximum. So now we are this time we are getting the row wise. So in this row we have to allocate as much as possible, and this in this case we have to check which one is the minimum. Here already we have allocated. So now 70 and 20 and 40, which one is the minimum? 20 is the minimum. So in this case here demand is 14 and capacity is 10. So obviously this cell can get the 10. So after allocating the 10, this has been now cancel out, and now rest part just update it 9, and here the 2. And in this case we have to update, so we'll get the 4, and here 7. This has been cancel out, and now row wise also cancel out. So now what is remain? Now again we have to check. This 2 has been cancelled out, this 2 has been cancelled out. Now we have remain only this 4. So in this 4 again we have to repeat the same process. So what is again difference is we will get the difference. What is difference we will get now? We'll get the again difference the 10, and here again get the 20, and obviously this has been finished. And in this case we'll get the difference. Now only we have this has been finished, so only this difference is here the 50 minus 40, that means 10, that is cancelled out. And here we are getting the difference 60 minus 10, that means 50. So again check which one is the maximum. So 10, 15 and 20 and 10, which one is the maximum? So 50 is the maximum, that means we have to choose the column. So in this column we have to allocate as much as the possible. So in this column only in these two, which one is the minimum? 10 is the minimum, and here 2 is the capacity, and demand is what? Demand is 4. 5 allocated and 10 allocated 4. So now if we give the 4, 5, 9, okay, something we are missing, and where we are missing we have allocated the 5, then 2, here allocated the 10, then we are getting the 4 remain. If you okay only 2, okay only 2, capacity is only 2, and here demand is 4 and capacity is 2, so only we can give it to the 2. So rest 2 is again remain, in this case 10 and 2 4, so we can allocate to this one. Now what is remain? 7 is remain, so we can allocate the 7 here, and now everything now I think okay. So just check it. 5 plus 2 7, that's done. 7 plus 2 9, 10 plus 8 18. Now column wise 5, this is 8, here 7, and now 2 to 4 and 10 14. So now this is balanced, and now this is the initial feasible solution. 1 2 3 4 5 6. These 6 are the initial feasible solution of this TP by Ojel's approximation method. So x11 equal to 5, x14 equal to 2, x3 3, x23 equal to 7, x24 equal to 2, x32 equal to 8, and x34 equal to 10 is our required initial feasible solution by the Ojel's approximation method. So you can write here the solution. If you want to write, then here we can write, obviously write the solution, means we are getting x11 equal to 5, x14 equal to 2, 2 3 equal to 7, x2 4 equal to 2, x3 2 equal to 8, and x3 4 equal to 10. 1 2 3 4 5 6, 1 3 and 3 6 is the required initial feasible solution of this given transportation problem. So we will discuss more PYQ in the upcoming videos of also of the assignment problem and the duality and simplex, so on. So we will meet again in the next video. We will discuss about the some more problems about the linear programming problem. Thank you.